If you live in Oregon City, West Lynn, or Gladstone, when you take a shower, drain your sink, wash your clothes, or flush the toilet, chances are your water will end up here at the Tri-City Water Resource Recovery Facility. A network of pumping stations and miles of piping collect wastewater and feed it to the Tri-City facility in Oregon City, with additional wastewater arriving from the Kellogg Water Resource Recovery Facility in Milwaukee during high-flow events. Located near the confluence of the Clackamas and Willamette Rivers, the Tri-City facility can treat and clean up to 60 million gallons of wastewater per day, although it averages closer to 12 million on a typical day. The facility began operations in 1986 with a conventional treatment that utilizes physical, biological, and chemical processes to treat and clean wastewater. This process includes bar screening and grit removal, which takes out solids from the wastewater stream, treatment with aerobic and anaerobic bacteria, and finally, the use of chemicals to remove any remaining contaminants before the water is returned to the river. Additional capacity and upgrades have been added to the facility over the years. One major upgrade was the addition of a membrane bioreactor treatment process, which strains wastewater through extremely fine membranes to remove contaminants and treats the water with powerful ultraviolet lights. Both the conventional and membrane bioreactor treatments run simultaneously, allowing the plant to treat wastewater while being able to accommodate high flows experienced during wet weather. In addition to the treatment processes, the Tri-City facility has a number of features designed to reduce its impact on the surrounding environment. The Tri-City facility uses digesters, which are large tanks where anaerobic bacteria decompose solids in the absence of oxygen. One of the byproducts of the digestion process is the production of biogas that is used to help power and heat the treatment facility. Green features such as green roofs, swales, permeable pavement, and a retention pond have also added to the Tri-City facility. Prior to these green features, stormwater on the plant site went directly into the Clackamas River. These features create a buffer during storm events, and since the features were added in 2011, WES is proud that all stormwater runoff has been contained to the Tri-City campus and away from the Clackamas River. The Tri-City Resource Recovery Facility recycles energy, reuses water, and produces some of the cleanest effluent, which is treated and cleaned wastewater in the country, which is then discharged into the Willamette River. Primary clarification, secondary clarification, headworks. Untreated wastewater that arrives at the Tri-City facility is called influent. The first stop the influent makes is a 48-foot deep wet well. The influent is pumped into the plant with a set of 5 pumps from the well and sent to the screenings building. This is where the influent passes through a number of screens of varying sizes. These screens are made up of a series of closely spaced bars, starting at 1 inch apart, 5/8 inch apart, and 3/8 inch apart. The screens are designed to prevent anything larger from passing through. They're periodically scraped clean, and the material captured in the screens is gathered together and eventually sent to the landfill. The material trapped in the screens is made of just about everything that is flushed down the toilet or sent down the drain. Removing this material protects the equipment and processes further downstream in the treatment. Once the large pieces are removed in the screens, the effluent is pumped into one of 2 grit chambers. These are aerated chambers. Here the effluent's flow is slowed down, allowing sand, rocks, and other grit to settle. The grit is then pumped up to grit classifiers, and it's further washed and then de-watered and will eventually be sent to the landfill. After grit removal, the effluent is sent to the primary clarifiers. These are rectangular chambers about 20 by 120 feet and about 12 feet deep. This is where remaining solids sink to the bottom as sludge or rise to the surface as scum. Both the scum and sludge are removed and sent to the digester, a large tank where they will be treated with anaerobic bacteria. The Tri-City Water Resource Recovery Facility uses 2 processes to treat wastewater: the conventional activated sludge process and a membrane bioreactor process, or MBR. Both treatments go through the screenings, grit removal, and primary treatment processes. Effluent that will be treated in the MBR process is diverted at this point for finer screenings. Effluent being treated conventionally is sent to the aeration basins, a tank where oxygen is pumped into the effluent mechanically. This promotes the growth of bacteria that thrive in oxygen-rich environments. These bacteria help break down the waste material in the effluent by breaking down organic matter into carbon dioxide and clean water. After being treated in the aeration basins, the effluent is sent to one of two secondary clarifiers. These are 120-foot round tanks where scum and sludge are further removed and sent to the digester, where it will be treated in an oxygen-deprived environment or anaerobic environment. After the secondary clarifiers, the water is given a final chemical disinfection with sodium hypochlorite. Membrane bioreactor. The membrane bioreactor process, MBR, has earned an industry-wide reputation for being a model of sustainability as it saves both energy and precious water resources. Added to the Tri-City Water Resource Recovery Facility in 2011, the MBR's advantages is that it can treat wastewater using a much smaller footprint. Thus, more water can be treated in a smaller space. After primary treatment, some of the effluent is diverted into the MBR rather than being treated conventionally. This is a treatment process that uses hollow fiber membranes to treat the wastewater and remove contaminants. The MBR process is used simultaneously with the conventional process in the Tri-City plant and typically treats 4 million gallons per day, with the capability to treat up to 10 million gallons per day during peak flow. The amount treated in the membrane process is determined by the plant operators and depends on the conditions. Before being sent to the membrane bioreactor, the diverted water is further screened in the fine screening building. The fine screens are made of panels perforated with small 2-millimeter holes that remove the finer material that may otherwise cause damage or undue wear on the equipment downstream. The removed material is sent to the local landfill. The wastewater is sent from the fine screen building to the MBR aeration basin. This is similar to the aeration basin used in the conventional process. Oxygen is blown into the basin, promoting oxygen-loving aerobic microbes. These microbes eat the organic waste, breaking it down into carbon dioxide and clean water. To avoid spreading unpleasant odors, air from the aeration basin is sent through a biological odor control tower, which mixes nutrient-rich water, odor-neutralizing microbes, filters, and gases from the aeration basin. After the aeration basin, the water flows into the membrane bioreactor for membrane filtration. This consists of a large, deep tank filled with cassettes holding membranes shaped into long strands. The strands are hollow on the inside. Each membrane train has 131,000 square feet of surface covered in thousands of tiny pores. There is a vacuum pressure at each end of the fiber that draws water through the pores into the strand, resulting in extremely pure water. Scour air is pumped into the tanks to keep solids from sticking to the outside of the strands, and the water flows through the tank and is sent back to the aeration basin, with some of the solids being sent to the digesters. The water that has been drawn through the membrane fibers is pumped into the UV building, where it is exposed to powerful UV lights. The UV lights sterilize any remaining microbes in the water, thus disinfecting it. Digester complex, disinfection, out to the river. The Tri-City facility relies on the commonly used anaerobic digestion process. Digesters are 1 million gallon volume tanks used to process the solids extracted in the treatment process in an anaerobic, oxygen-free environment. This anaerobic environment allows microbes that can break down the sludge to thrive. After the solids have been decomposed in the digesters, they are dewatered in centrifuges. The resulting material can be used as a fertilizer on non-food crops. Gases such as methane and carbon dioxide are produced in a digester, just as in the human stomach. The creation of biogas is helpful as it is used as an energy source to help power the facility. Disinfection is carried out in one of two ways at the Tri-City Water Resource Recovery Facility, depending on whether effluent source is from conventional treatment or from membrane bioreactor treatment. Effluent from conventional treatment is chemically treated with sodium hypochlorite, which is a common chemical used at many wastewater treatment facilities. The recent switch to sodium hypochlorite significantly reduced the risk associated with chlorine gas, which had been used at most treatment facilities in the U.S. for decades. Sodium hypochlorite provides a much safer workplace for West employees and the surrounding area. After disinfection, the water is dechlorinated using sodium bisulfate. Effluent from the membrane bioreactor treatment is disinfected using UV light. Water discharged from the MBR is exposed to powerful ultraviolet light. Although this light doesn't kill all the microbes, it damages their DNA and makes them incapable of reproducing. Streams from both the conventional activated sludge process and the membrane bioreactor process are combined in the mixing box in the UV building, where it is analyzed and checked for compliance. The combined treated water is then piped to the flow control center, where it is distributed to one of 3 42-inch discharge pipes for discharge into the Willamette River. Typically, 2 of these 3 pipes are used only in the winter, with the other being used for summer operations. The Tri-City Water Quality Lab performs more than 20,000 analyses per year, including hundreds of tests per month on the samples collected from Tri-City. The goal is to ensure that the samples meet discharge requirements for the Willamette River and to provide information to optimize operations at Tri-City. In addition, samples are also analyzed from the other West facilities and surface water programs. Green features and on-site stormwater treatment. Managing on-site stormwater runoff is a critical piece of the Tri-City Water Resource Recovery Facility. In the past, on-site runoff from storm events such as heavy rains often ran into the Clackamas River, causing pollution and furthering erosion on the site. In 2011, a number of upgrades were made to the Tri-City plant, including the addition of the membrane bioreactor. As part of these upgrades, a number of green features were added to address stormwater runoff at the Tri-City Water Resource Recovery Facility. One feature is the addition of bioswales. These are a kind of vegetated ditch or man-made wetland. Stormwater gathers into the bioswale, and the plants and soil act like a filter, absorbing contaminants in the runoff and allowing water to absorb into the ground. Bioswales can also retain more water than traditional gutters, thus evening out peak water events. Another feature was the use of pervious pavement. Most conventional pavement is impervious to water, which means that runoff gathers and pools into gutters instead of soaking into the soil. This runoff also tends to contain contaminants such as residual oil and fuel from the roadway. Pervious pavement is a kind of pavement that is porous. It allows rain to soak through the pavement. Layers are added underneath that help remove pollutants before being absorbed into the ground. Green roofs were added to many of the new buildings. A green roof is a roof with soil and plants. It naturally absorbs stormwater, slowing down and evening out runoff, and the roof helps to absorb carbon dioxide, improving air quality. It also helps to insulate the building and regulate the temperature inside. Green roofs are fairly self-sustaining and don't usually require a lot of maintenance. A water quality pond behind the Tri-City plant is now being used as a retention pond, holding overflow from other green features such as the bioswales and green roofs. The pond also allows slower absorption of the stormwater into the ground. It also provides a more natural separation between the facility and the scenic bikeways and trails that run behind it. Overall, these measures have been highly successful, creating a capacity to absorb heavy rain events. Since their installation in 2011, WES is proud that all of our stormwater runoff has been contained on site.